Hello friends, welcome back to my channel. Sorry I was not able to post videos in the past few days, but I'm back with another video, and as always this will be on problem solving. So this question which you see right in front of you is from Argentina Maths Olympiad. Argentina Maths Olympiad. Now this thing says that show that the number n equals 444. This four fours are n times. These eight are also followed by eight n times, minus one followed by three and minus one times two. For example, if n was small n was one, then this number would have been 48 minus n minus one. That means 0 threes 36. It is true. Again, let's come back. So if it is was n was 2 plus 4488 minus 130, oh sorry, my mistake, minus 132, 6 5 4 4 5 6. This is also perfect square. Now similarly we have to prove that for all these n, this number will always be a perfect square. So before looking at the solution, glancing at the solution, I want you all to try this question yourself. This is a very interesting question. I can bet you will find pleasure in it. So try it yourself, and if you are able to do it or not able to do it after a lot of time, then come to the solution. So let's begin the solution. So we can type this first number, write this first number like 4 4 4, or simply let me erase this thing, or simply we can write this as 4 into 1 1 1 1 1 1 dot dot dot. This is n times into 10 to the power n, because these n8s will cover up the place, plus 8 times same case 1 1 1 1 1 1 n times. So here's the number. So there is a trick I learned in GP chapters, that multiply this thing by 9 and divide by 9 too. So I will do like 9, and I will replace these ones with 9. Here to the same, let me use a different color. 9 9 9 9 and so on to 9. This to 9 9 9 9 dot 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 till 9. Now this thing is actually n nines, and n nines are equal to 4 by 9 times 10 power n minus 1 times 10n plus, again, oh I forgot to mention 9 times 10 to the power n minus uh, minus 1. So this is the first number, first expression. Let me write it somewhere. So I will write it here. So this is actually 2 over 9 10 n whole square for 9 and 10, then minus 4 by 9 times 10 power n. Now we wrote this term. Let me erase this thing off. We wrote this term. Time for this term. Let's leave this term as it is by just replacing them with 10 to the power. Now coming to the next part, this can be written as 1 in 10 to the power n. Why 10 10 to the power n because there are n minus 1 3s followed by 1, so there are n minus 1 plus 1 n digits, plus 3 times 1 1 1 1 1 1. These are also n times, and this, because we have to do the last number as 2, I'll subtract 1 from here so that the last number becomes 2. So it is 10 to the power n plus again similar process minus 1. Now we have to subtract this big thing to this big thing. We add a minus over here. This thing, the 3 by 9 n simplifies to this expression. It simplifies to plus, let me expand this. This thing simplifies to 3 by 9 minus of 1. So now let's proceed. So we have got this thing, we have to subtract. Now let's do the subtraction. We will leave this term as it is. Minus 4 by 9 times 10n plus this, we get 4 by 9 times 10n, minus 10n, we get minus 5 by 9 times 10n, and this is plus 3. So from this thing we get, let me write this thing as first as it is, 2 by 3 minus 2. This 2, it must be then 2 by 3, so 2 by 3 times square, and this would have been minus 8 by 9 times 10 power n, and this is minus 8 by 9. Here I have minus this thing, so this will become positive, minus minus become positive, so plus 12 and minus 5 leads me to 4 by 9. So this huge expression reduces down to this much only. So let's erase all the rest stuff. Now you can see some form. I think you are familiar with this identity if you remember it, or if you don't, keep watching. So this is nothing but actually, let me use a different color. So this is nothing but actually 2 times 3 power 10 n whole square. Let this be a minus 2 times 2 by 3 times 10 n a times 2 by 3. Let this 2 by 3 be b plus 2 by 3 whole square, and this one reduces down to this thing reduces down to a perfect square clearly, 2 by 3 10 to the power n minus 2 by 3 whole square. Now 2, you can simply write this thing as 4 by 9 times 10 n minus 1 whole square. So you can clearly see this thing is a whole square, so this number is actually really a whole square. This was a very interesting question though. Now how to prove that 9 must divide this thing? So we clearly know that 10 is congruent to 1 modulo 9. Now powering both side by n, we get 10n minus 1 congruent to 0 mod 9, clearly depicts 9 divides 10 n minus 1, so we'll divide 2 and the second square of it. Now similarly we have proved that this is an integer, hence this number is always a perfect square and it is an integer. So let me leave you again with an assignment as always we do. So the assignment today is you have to prove something similar. Prove that this sequence 7 2 9 comma 7 1 2 8 9 comma 7 1 1 2 8 8 9 comma 7 triple 1 2 triple 8 9 and so on is always a perfect square. This is 27 square, this is and so on 267 square, 2667 square and so on. You got to prove this is each and every number of this sequence is a perfect square. Hope you enjoyed this problem. Give this one a try so that whatever I taught you might become more clear, crystal clear. Now let's discuss the solution for the problem I gave in the previous video. It was xy, it was from a Baltic MO plus yz plus xz equals 3xz, and we had to prove x square y plus y square z plus z square x greater than 2 times x plus y plus z minus 3. So if you haven't tried this problem, I'll still suggest give it a try. And if you have or failed at it, see the solution. What was the trick was to replace this 3 with 1 by x plus 1, as it is evident from here. It is 1 by x plus 1 by y plus 1 by z equals 3, and we had to replace this 3 with that term. So what was the trick was x square y square by AMGM. I taught what is AMGM. If you don't know, you can watch the previous video. Is greater than xy. Dividing both sides by y, we get x square y plus, or let me bring that to the other side. So this is actually greater than 2x minus 1 by y. What I did is I divided both sides by y. Similarly for x square, sorry, for y square, z we have 2y minus 1 by z. For z square x we have greater than this term greater than or equal to 2z minus 1 by x. All we had to do is sum all these three and we'll land to the answer this thing. So if I add all those three, I will get something like this term x square y plus yz y square z plus z square x greater than 2 times x plus y plus z minus 1 by x plus 1 by y plus 1 by z. You just needed to replace this 1 by x plus 1 by z plus 1 by y by 3 as it is given here in another form. That was a trick. So replace and we'll go there by 3, hence approved. Thank you for watching. Stay tuned for more videos. Thanks. Subscribe to my channel, share it with your friends, family, everywhere. I hope you like this video. Thanks.